Okay, so I know that we're talking about the phylum Mollusca, and I'm going to talk to you a little bit about pH, and you might wonder what that has to do with this phylum. It has to do with what human activity is doing to the oceans, and since most of these guys live in the oceans, it's having an impact. Now, there's some basic background knowledge that you need to understand a few of these concepts. And the first thing that I need you to be familiar with is something called the pH. Okay? And some of you are already familiar with this, but the pH scale. Now I've thrown down some words that might help you out. Acid, acidic, acidity, acidification, lower pH, which means to make more acidic. Neutral, which is a pH of 7, not acidic, not basic. And a base, we can also say basic and an increase in pH. So I'll refer back to those words. So this scale that you can see here, this is the pH scale. And it goes from acidic on one side to basic on the other side, with neutral being in the middle. Now, a couple of things about this scale. First of all, it's a logarithmic scale. And what that means is every time you change a number on pH, whether it's an increase or a decrease, every number is a factor of 10. So a pH of 7 is 10 times more basic than a pH of 6. Okay? And if we go two number places, two number values, that's another 10 times. So a pH of 8 is 10 times 10 was 100, is 100 times more basic than a 6. So that's what a logarithmic scale means. So on this scale, anything below a 7 is considered an acid. Anything above a 7 is considered a base. If we are making our number, the pH value, smaller, we say we are increasing the acidity, or we can say that we're lowering the pH, or that we're making it more acidic. And that's anytime we're going in that direction. Anytime we're going in this direction, we can say we're making it more basic, okay, or we're increasing the pH. So all living things have a pH that they function the best at. And if you change that pH, even if it seems like it's a small number, that can have drastic impacts for a lot of living things. Most living things do best if conditions in their external surroundings stay the same. So you can see on that picture there's some basic household items for the most part, and they're different pHs. So something like lemon juice has a pH of 2, so it's really acidic. Not as acidic as gastric acid, which is in your digestive system. If we compare that to something like bleach, bleach is very, very basic. Baking soda, an egg. Okay, and so all of these things have a different pH value, and having a high pH, so more basic, or having a low pH, more acidic, doesn't necessarily mean one thing is more dangerous than the other, meaning that an acid's not necessarily more dangerous than a base. Both of them can be dangerous. Both of them can be necessary too, depending on what we're talking about. So if we look at the ocean and what that has to do with what I want to talk about today, the first thing that I want to show you, I'm going to be looking at this picture right here, is from that picture, you guys know that we're increasing the amount of CO2 in our atmosphere, and that's leading to something called climate change. Now, CO2, the sources of CO2 naturally, come from the burning of fossil fuels. Okay, and fossil fuels are things like gas, oil, propane, natural gas, charcoal. And so as we do human activities by using these fossil fuels, we are increasing the amount of CO2 in the atmosphere. Okay. Now, and that causes climate change, but it can also cause something else in the ocean. So here, the CO2 that's in the atmosphere gets dissolved into the ocean. And once it is dissolved into the ocean and it mixes with the water, it forms something called carbonic acid. And this ends up lowering the pH. Now, since the Industrial Revolution, the pH of the ocean has lowered from 8.19 to around 8.05, and it's going lower. Now, that doesn't seem like a big decrease, but remember the pH scale is a logarithmic scale. So this change actually translates into a 30% increase in the acidity of the ocean, which is actually a fairly big change. And that's going to have consequences to living things in the ocean. Now, if we look at the chemistry of this in a nutshell, meaning very, very simply, CO2 emissions absorbed by the oceans, like I was saying. CO2 and water form carbonic acid. And then what that does is that creates more hydrogen ions, which is what's actually making the water more acidic. And at the same time, it's decreasing the amount of calcium carbonate that is present in the water. And that right there ends up being a pretty big deal to mollusk. So does the water becoming more acidic. Okay, and I'm going to show you why. So it turns out that most shells in the ocean, all shells, so if it's a marine snail, so a gastropod or a bivalve, their shells are made out of this substance, calcium carbonate. So are the structures that corals build. So you remember the corals are made up of those little polyps, and those polyps make those kind of rock-like structures that they live in. And that's what a coral reef is made out of. And that's all made out of calcium carbonate as well. So what does that do? And let me show you. I made this cool little home video. So let me try to get it going. So what I have here in this picture is I have a control. And that control is over here on the left-hand side of your screen. I'm trying to get my pen working here. Groovy, that should work. Okay, so this is the control, and this is my experimental. Now it turns out that common chalk right here, this is made out of calcium carbonate, which is CO3. Now, the control is like the ocean with its normal and correct pH. And you can see what happens to the calcium carbonate when it's in the water. Now on the right hand side, I'm going to place the calcium carbonate, the chalk, into some vinegar. And vinegar is a weak acid similar to carbonic acid. So this is going to represent the calcium carbonate interacting in the carbonic acid. So let's check out what happens. Let me play this. It's a time lapse. So there's the chalk. Put it in both containers, one with water, one with vinegar. So you can see the one on the right, the experimental with the vinegar. There's obviously a lot of action going on there. A lot of bubbling. The water's getting cloudy. That cloudiness has to come from somewhere. It's coming from the calcium carbonate breaking down. So not only is there a decrease in calcium carbonate in the ocean because of the pH change, but it also softens up and dissolves the calcium carbonate that makes up the shells or the reef structure. So this is called the acidification of the oceans, and it can be a very, very bad deal.